I tried to close this down, but every time I talk, it hears me and I'm in there, so.
Okay.
Our mic's picking up my voice, so when I open this up again, it'll put the video back.
And I'll have to turn my mic up again. Or actually, oh, I think I didn't turn the mic down. I turned the audio down.
Yeah, which is fine.
Yeah, that works.
Easier, I feel like teleconferencing is getting harder rather than easier because every meeting, every 5 minutes, no matter what job tool we use, we spend it connecting.
Trying to get connected. And, well, that's why we set this up early.
Yeah, I know.
Like I tried it last night just to make sure because the first time we did this, it didn't go so smoothly. Help yourself. Yeah, basically, I got those at a previous conference, and it's like, you know, I have all the ones I want, and it's like these were like extras because basically I kept walking by the table. It's like, hey, they still have a lot of these on, so it's like, I'll take a little more. It's like, I'll bring it to the meetups, and then the meetups kind of faded. And it's like, I have all this extra crap.
Some of my badges from my summer Groovy class.
Absolutely. Okay, let's see. Well, it's not champagne. It's wine because I'm a wino. And I don't like beer, but and since I left, they don't stock wine anymore because I was the only one who drank it. Like if there's any wine left in the fridge, which they didn't put out, might be a little ripe. Okay.
How are you doing?
Moseying in.
Oh, it's almost time, isn't it?
Yeah, I'll give a couple minutes just to get some mosey in, but.
Everything's right.
Oh. Every time I hear my voice, it switches over.
Yeah, it's going to do that regardless.
Which is fine once we start.
Yeah.
Now it's a little awkward. So I'll try to stay quiet while you talk.
Try to see if there are people online. I don't, because I've never done this part. So we have viewers. We have someone who's watching online. So. All right, cool.
Is there somebody we should tweet it? So there's no Twitter handle I should tweet there.
What's that?
There's no Twitter handle I should reference if I tweet about it.
No, well, I think, yeah, I don't even know what mine is. I hardly ever use it, so.
Thanks.
Okay, let's see. So there's a few that we need outside.
Yes.
Start soon, though. So, Amr, there's a few people still outside?
Yeah. Let's give them a minute.
Yeah. That's just so I can get my screen back afterwards, because otherwise it's Linux, and it sometimes with multiple screens does not play nicely with me. Unless I have it set up exactly like the config, it'll work. But because I have a tri-screen thing at home, and if I have it set up, it works. Otherwise, it goes all wonky on me. It's like it'll display one way or another. So
They're waiting for you.
okay, I think we have one more coming in. So we're all set?
One more group on outside if you want to.
I'm sure they'll make their way. Yeah.
All right. I guess I'll at least start with basic announcements. So welcome everybody to Boston Groovy Grails Spring Meetup, which has become a mouthful since we had spring. But anyways, trying to get more people into this. So just trying to get it back on track. We got Ken Kousen speaking tonight. So I'm just going to go through a few quick announcements to start. So the first thing is we need more speakers. We need you. Any of you, like if you have have done like a plugin, a library, or have some knowledge that's Groovy Rails Spring related that you could give a presentation on, we would love to have you. So far we've gotten Ken Kousen, we've got Yannis over here, and you don't have to be Ken Kousen. It's like he's a really great speaker, but I know I'm putting
pressure. Yeah.
I'm putting up on the pressure, but basically, in order to keep this going, we're going to need more speakers. Like I can do a few more talks, but it's like if it becomes just the Tucker show, then this is going to get probably a little stale and boring. So
Also, the other thing that we could mention is that maybe we can have kind of 2 or 3 sort of.
Oh yeah, absolutely. The other thing I should say is we are interested in lightning talks too. So we have a really short talk, and we can get like a bunch of those, and it will take a little bit more coordination because we'll need to get like more people, but we're definitely interested in doing that. And maybe like one meetup we'll just do like a birds of a feather session and just like have people and talk to each other about our experiences or something like that. But so other than that, I want to thank Nielsen for providing this nice space, the food and booze. So that definitely helps. So thank you for that. So this might become a semi-regular place, just because for me it's somewhat convenient. But I will try to still do it somewhat in Boston, but with that, the places that I know in Boston, we won't get free food and booze, so trade-offs. Also, just like I mentioned, that the G3 Summit is coming up in November 28th to December 1st. This is a really great conference. If you can convince your company to send you, it's definitely a good place to go. I think it's like 1,200 for the conference. And there's going to be a lot of good speakers there. It's actually even bigger than Spring 1 CX. It's going to have, I think, 5 tracks this year. So it looks like it's going to be a really, all the people who do Groovy Rails, minus I think a couple like Bert Beckwith is going to be there, but pretty much all the other big names are going to be there. So definitely check that out. Just to plug my own plugin, I just released Enforcer. Which is a plugin for enforcing business rules, kind of an alternative to Spring Security ACL. Uses ASC transfer, so it gets around some of the nasty issues of Spring Security. If you're aware of the Spring proxy issue, if you're not, you might have security holes in your application. So check that out if you're interested. And basically, I'm going to open up to the floor. Like, if you have any announcements that you want to make, like that are Groovy related, if you have jobs that are Groovy related, stuff like that, we'd like to hear. Trying to go off the pattern of DJub. So.
Hi, I'm a senior engineer team lead at Funders. We're very heavy screen users. I'm trying to gradually get Groovy indoor, and I'd be happy to have allies in that. We're growing fast, always hiring because let's say how harder is this lead. When I joined, it was the number 5. So and great place to work, very mellow, partly because we don't have any direct customers. even to sort of like essentially no too much of anything. So we just get things done, but very well for us. But, we're just on the top. And right here, the Galleria and Research Science. So, okay, these people walk from those
Okay, having some issues with my monitor now.
Is it because I'm sharing and I'm already joined?
All right, so I don't know if you're sharing and
Want me to stop the sharing?
no. Let me see if you're on. So that's good. So basically, I should just function.
While he's getting everything set, let me. I'm going to have to unfortunately sit down for most of this, which is good on my back, but it's hard on you because we're going to do this through Google Hangout as well, and that means the camera's going to be pointing at me. Although I guess if I'm showing my screen, it won't be pointing at me. This is better and better. All right, let me give you an idea of what I'm hoping to talk about today. I've been spending a long time in the Groovy and the Rails world and Gradle and things like that. And I am scheduled to give a talk at Java 1 in 3 weeks? 3 weeks, 2 weeks, 3 weeks, something like that. And one of the ones that was accepted was a talk called Groovy and Java 8, making Java better, which I was surprised that they accepted, but I put the word Java 8 in it, hoping that would because I was there a couple of years ago, back in 2013, and I got a talk accepted about making Java Groovy, and that one went really well. Last year I proposed a couple. I was working on a book called Gradle Recipes for Android, and I knew that the words Gradle and Android were not really going to apply at Java 1. I tried saying I was doing something Gradle build tools for mobile, hoping that would sneak it in. It didn't work, unfortunately. But this time I'm giving this talk. Now, I got to admit that the talk's not ready yet, so I'm using this partly as your help to tell me what I should include and what I should not. Now this, I'm assuming this is a group that's quite comfortable, at least with Groovy, right? And I guess I have to ask, how many people are using Java 8 at this point? Only about half, a little bit less than half. So okay, so I'll fill in some of that background. I expect to see the reverse at conference. So what I've mostly done is I have minimal number of slides. I have a ton of code examples. I've got everything to the GitHub repository. I'll give you the URL for that. Plus, when we finish and as I build up to the talk, I'm going to be adding and modifying things in our repo. You'll be able to check that out anytime you like. It's all open to the public. I have no problem with that. If you find an error, please let me know. Send me a pull request. Right now the tests all pass. The only problem is I don't have enough tests. But I suppose do you ever have enough tests? Yes, you do actually. I've run into companies that have too many tests. Yeah, I actually ran into a company working on a Grails project, and the woman I was talking to there, outstanding developer, said that she had this problem where they actually spent 2 days writing a test on code that took an hour to write, because they were doing very UI intensive stuff. It was really awful, but I tried to tell them that wasn't necessary. At any rate, so I want to talk to you mostly about the new things in Java 8, meaning the streams and the lambda expressions and method references and all that kind of stuff, and then how that interacts with Groovy and what Groovy brings to the table in addition to that, how it goes beyond what Java 8 happens to have inside it by itself. So that's where I'm focused on this. The hard part for me at the conference will be that talks at Java 1 are roughly an hour or less, whereas I'm on the No Fluff Just Stuff tour. I recognize several of you from the tour, I think. And we talk for 90 minutes on a regular basis, and therefore I'm in the habit of talking for 90 minutes, so squeezing it down. But I promise I won't do that to you tonight, okay? But I will say I have much more code in the repo than I have time to talk about tonight, because I figured this was going to be kind of a proof of concept and kind of an interactive difficulty here. I figured I'd wear this shirt to prove that, Okay. I'm ready to take whatever you dish out here, you know. Yeah, I've also,
very adventurous with
and
red
later
shirt.
I'll show you the toy. Oh, yeah. Shoot, it kept turning off. That's the problem. Okay, is it ready? There we go. And it is, in fact, Bluetooth connected to my phone and everything. So, all right. So do your worst, and whatever you do, I'll take advantage of when I get to the, oh, you've got an easy button or whatever? Yeah.
Which I got known for when I used to work here, the bullshit button.
So whatever feedback I get, I'll take advantage of to build up the talk for Java 1. Okay, oh, by the way, I'm based in Marlborough, Connecticut. So not Marlborough, Mass. I'm about 2 hours away, to give you an idea. So this is, I suppose, my local group when you come right down to it. We do have a Java users group in the Hartford area, but it's very small. It's not terribly active. It's nothing like Meetup, you know, which I think Meet's only about a mile away from here, right?
Yeah,
Over a
and
constant contact.
They've had like you know, up to 100, 150.
Yeah,
to that.
that's the biggest one I've
well,
ever.
you've been there a few times.
Well, I got to speak at that one, and that's the biggest one I've ever spoken at, or the biggest Java users group. But it's nice to have a Groovy and Grails user group. These are my peeps, you know. I feel
Trying to bring
it's
it
my
back.
tribe, if you will. I'm very comfortable here. At any rate, let me just get the couple of slides out of the way, because, like I say, the rest of this is going to be all code. So just for my own contact information, and I will send these slides when they're done to. I keep wanting to call you by your Twitter handle, but I'll send them to Tucker, right? And then
Tucker, Virtual Dogbird, either one.
I know it cracks me up. But at any rate, my name's Ken Kousen. It's Kousen like the relative, even though it doesn't look like it. We think it's an Ellis Island job. You know, nobody knows what it was in the old country. My company, such as it is, I'm a one-person company. It's called Kousen IT Incorporated, although my wife says Kousen It. You know, was her idea, actually. There's email address, my homepage. I've got a blog at WordPress, because that's more likely to be up. You know, there's my Twitter handle. I'm also the co-host on the Groovy podcast, which is partly hosted. They have a page by the No Fluff Just Stuff conference series, and also, so what I've done is I wrote a book for Manning about. Was published, I can't even believe it, September will be 3 years. It was published in 2013, called Making Java Groovy. And that was a Java Groovy integration book, basically what do Java developers do and how do you add Groovy to make your life easier. And the book that I just wrote for O'Reilly is called Gradle Recipes for Android. That's only of interest to you if you are actually building Android applications, really, because it does have a lot of Gradle stuff in it, but it's all focused on building Android apps. The Gradle book you can purchase if you want physically, but if you only want to take a look at it, if you register at gradle.org, you can get it as a free download in the PDF form. Of course, you can buy it if you want. I should give you, at least as a reward for your willingness to sit through this nonsense, let me give you a couple of coupon codes, okay? So for the Manning one, they put in this coupon code, and I think they forgot. So I keep giving it out, hoping that they don't delete it. The coupon code for any Manning book at all, you have to do this at manning.com. Okay, it doesn't work at Amazon or whatever. Manning.com. It's my last name, all lowercase, Kousen, followed by the number 37. That'll give you a 37% discount on anything at Manning. You just have to have my book in the shopping. No, you don't.
Yes, you do.
I'd love to say that, but no, you really don't. So at any rate, that'll work on all Manning books, including the early access ones. Now, Amazon sometimes will beat that, but at Amazon, you can only get the print book. You can't get the ebooks. At Manning, you can get anything. At Amazon, if you do buy the print book at Amazon, by the way, just go register it at Manning, and they'll give you the ebooks for free. So either way, Kousen 37 gives you 37% discount. You can try Kousen 85, see if that does anything. If you really think it through, though, you try Kousen 105 and see if they'll pay you to take it away, right? At any rate, so that I know the 37 one works. Also, on the Gradle Recipes for Android, now I understand that you can get the book for free, the ebook, but if you do want to purchase anything at shop.o'reilly.com, so that's the official site for the O'Reilly stuff, is shop.o'reilly.com, then this coupon code is all capitals, 5 letters, AUTHD, D is in Dogbert, right? Auth D, I don't know where they came up with that. That'll give you 40% off of books and 50% off of videos. Okay, and I mention that because I have a whole bunch of video courses out there as well, including several on Groovy-related topics. If you have a Safari subscription, by the way, these are already available to you, all as part of Safari. I think I've got like 8 or 9 of them now. We just put up one on advanced Java somewhere, and oh, there it is. Quote advanced, you know how that is. They don't think they could sell anything. It's got the word intermediate on it, so it's called advanced, but you know how it is. We're at the end of September, I think we're going to record a Grails 3 one. So that's coming. The rest of it, just let me know what you're interested in. Okay, that is all the self-marketing I could stomach. Let me go back to what I was doing. Okay, so I just put a little list here just to keep track of the things I want to address. I don't know if I'll have time to cover everything, but let me at least give you an idea. So we will talk about lambda expressions in Java 8, what that means, how they look, what the syntax is, and more importantly, how they're different from Groovy closures. You know, where do Groovy closures work better, where do lambda expressions make more sense, etc. And then the syntax for method references as well. It's part of Java 8. And it's hard to talk about those in isolation without talking about streams. So that'll all be involved. And one of the things I'm going to show you especially is how streams are lazy and how that can pay off, how that can help, because it's a programming model that is somewhat new to a lot of people. Even people who've been coding in Java for many years have a transition to make to start thinking that way. Even though I've been in Groovy for a long time, I did have to think about it because it really is a different idiom for Java code. So I'll show you lots of examples of that. Of course, that brings up the whole map reduce, or really more properly in Java, it's map filter reduce paradigm or approach, where instead of ever iterating again, that's an exaggeration, of course. When you're normally tempted to iterate, it's better to transform using a map method, and then you can filter to only the elements you want, and then reduce that down to either a single quantity or a collection again, and go on and use them over and over again. And this comes up in Java constantly now, or in Java 8 at any rate, and that'll continue in 9 as well. One of the things they've done in Java that is very interesting is that they have gone to great lengths to turn Java into SQL, as you'll see. If you've ever used any of the sorting capabilities in streams now with the sorted method and things that takes collectors, as we talk about, I'm going to talk a little bit about collectors, and there's a bunch of static methods in collectors to generate sorting mechanisms. And then, of course, in Groovy, I'll have to point out the AST transform called sorting, or sorted, rather, how easy that is. I don't know that we'll talk much about composition. See, the remaining things, everything up to collectors, is really all Java 8 stuff that Groovy does equivalently or differently, but it's all the same concepts over and over again. Then there's the stuff that Groovy does that goes beyond what Java does. Java doesn't really have composition in any real way. Closure composition, they have something, but it's not really traditional composition. Groovy does. Groovy has currying. Java can kind of fake it again. And then Groovy even adds things like Memoize and trampoline and things that get progressively more confusing as you go on. Groovy is still not a functional language. I don't want to pretend it is. It's an OO language that has functional concepts in it. Java did the normal Java thing, which is, all right, let's borrow as much as we can while still somehow maintaining 20 years of backward compatibility. And that's a hard problem. I got to give them credit. That is really tough, and yet they've managed to do that. If there's time, I also have a couple of amusing examples of the new java.time package, date and time. Groovy doesn't really add anything to that, but of course the syntax is simpler. But it's just, I have a couple of simple examples if you're interested. And that's just, I'm going to keep that list available just so I can refer back to it. I started putting together slides to talk about lambdas, and then I said, no, I'm going to spend more time on the code, so I don't have any more slides than that. So just to give you an idea. So with that in mind, I have two GitHub, pardon me, actually that's where I should start, isn't it? Let me show you the GitHub repository for all of this. Make my font bigger. My home base on GitHub is github.com/Kousen, my last name. And I have a whole series of repos there, and I pushed this one up today just to make sure it was there. It's called Groovy_Java_8. And all the code that I'm going to show you is either there now or will be there when we're done and everything. Feel free to clone that. And if you're not a Git user, there is a zip download and everything. I have a Gradle build file in there, which is very, very simple. Maybe I can just show that here as long as we're here. Is that I've got a Groovy plugin, and I didn't add the Java plugin. I told IntelliJ to build a Gradle project for me, and it added the Java plugin as well. Most of you, I'm sure, are aware that if you put in the Groovy plugin, that includes the Java plugin in Gradle builds. I did set the source compatibility to 1.8 just to guarantee that the things I'm using will work there. I'm downloading everything from JCenter. All I have is the Groovy all jar file. That's the latest version, and I have both JUnit tests and Spock tests, and that's it. So nothing unusual, nothing exotic. There's plenty of things I could have added, but I decided to keep it all simple and just focus on the functional aspects of the language rather than on extra libraries and things like that. Okay, so let me go to, oh, well, yeah, I don't want to go to that page. That'll look at infinity. Okay, I have two of these open. Oh, this is the one I want. All right, by the way, I am using IntelliJ. If you do decide to import the project into IntelliJ, just say import and drill down to the build.gradle file. That's just I'm surprised how many IntelliJ people don't realize that. If you drill down to that, then IntelliJ recognizes it as a Gradle project, sets it up accordingly, everything works fine. You could probably import it anyway, but that always works. Now, I have done something that I don't normally do, and that is, I don't know how well you can see that, I set up my project with both a source main Groovy and a source main, sorry, a little further, source main Java. I don't normally do that. I normally put everything under source main Groovy, both Groovy and Java code together, and I haven't had a problem with that for years. Let the Groovy compiler handle all the cross-compilation issues, and I've got Groovy classes that extend Java classes and implement Java interfaces, etc. Haven't had a problem with that for a long time. So I recommend that. This one I separated deliberately because this talk is focusing on how do you do it in Java versus how do you do it in Groovy, although there's at least one spot where I couldn't resist actually using a Java class in a Groovy script just to demonstrate that there wouldn't be a problem doing so. I also have my normal source test, Groovy and Java. I've got a JUnit test in the Java one, and the rest are Spock tests under the Groovy side. So let me start with lambdas. Now, how's that font size? Can you see that okay? Okay, your eyes are better than mine. What I've done here is I've just made a class with a main method in it at this point. So I'll get to things that are more testable, but this is just to do a demonstration. I created a list of strings, so this is an array list, very simply. And one of the things you find out when you start looking at lambdas in Java is that there is no class called lambda. This is in direct contrast to Groovy. Of course, Groovy has a class called closure with the call method and various other methods as well. And I would say this is an advantage to Groovy, but it's an understandable restriction that Java made. Now, if there's no class called lambda, then what do? And the idea is, for those of you who are not aware of it, a lambda expression never exists in a vacuum in Java. You can't just have a lambda expression. A lambda expression is always assigned to a context. And that context is a reference of type single abstract method interface, SAM interface, single abstract method. What do I mean by that? I mean, if you have an interface that has a single abstract method in it, then it becomes what they say the target of a lambda expression. I can assign a lambda to it, and basically what the lambda is the implementation of that method. If you're used to writing anonymous inner classes, my condolences, basically, conceptually, think of it as taking that lambda and having the compiler generate the anonymous inner class for you, where the lambda is the body of that single abstract method. Now, before I go on to that, just one quick mention for those, again, who are relatively new to Java 8. When you say single abstract method, well, the single sounds easy. That's easy to understand. But why am I saying abstract? All methods and interfaces are abstract, right? Well, that was true until Java 8. In Java 8, now you can have default methods that actually have a body and the keyword default on them. And you can have static methods, which also, by the way, have a body. And these are actually very effective and powerful in Java. They make a big difference, but that's why they have to make a distinction between abstract and non-abstract methods now. They've really blurred the distinction between interfaces and abstract classes. The biggest difference remaining is that you can't have an attribute in an interface, I mean, other than a constant. So interfaces don't have state, they only have methods still. But they may have default implementations on those methods. And if there's ever a conflict, you know, if you're thinking diamond problem and everything, anytime you implement a method in a class versus interface, class always wins, always. So anytime you have a conflict between two interfaces with defaults, you just implement that method in your class, you're fine. If you don't do that, it won't even compile. So with certain exceptions. But in general, that's the idea. So I'll show examples of some of that later. But in the meantime, I wanted to show there is a new interface in Java called consumer. They actually have added an entire package of new interfaces, java.util.function, that has a series of what they call functional interfaces. Now, by the way, a functional interface is a technical term. It means an interface with a single abstract method. And frankly, I should start there because here is the Java 8 API, which I'm going to magnify a bunch. So here's the Java 8 Java docs. And if I go down to the java.util.function package, too many notes, right? There it is, java.util.function. You can see all of these target types for lambda expressions and method references. And if I go down here, here is consumer, represents an operation that accepts a single input argument and returns nothing. And if you look at the consumer, it says at functional interface. They've added an annotation to identify which interfaces are functional interfaces. Now, if you're writing your own functional interface, by the way, that's an optional annotation. If you've ever used at override before, you know you don't have to put it on there on every time you override a method. But if you do, the compiler will check to make sure you overrode instead of accidentally overloaded. Same thing here. If you accidentally have two abstract methods, then this will not compile if you have the at functional interface annotation on it. If you don't, then you'll find out at runtime. Or, well, actually, you'll find out when you compile the program. But regardless, all the ones in the library all have at functional interface if they are. By the way, that's the other side effect of having at functional interface. This block right here, this statement, this is a functional interface, etc., is generated from the javadoc command from this at functional interface annotation. So that's two consequences. One is the compiler checks, and the other is you've got this block in the Java docs. Now down here you can see there are multiple methods, one of which is a default called and then. And by the way, this, in case we don't get time to talk about it, is about as close as they come to closure composition, because they're basically saying, give me a closure and then give me another closure, and we'll do the first one and then the second one, if you will. And they have various ways of trying to do that, but it's not very clean, certainly not like a true functional language would do. I mean, the Scala people would be scowling, and but they're not happy people in general. I'm not surprised. You know, they're always arguing about something. And the closure with a J people, they are very happy, but they're off in their own little world anyway. You know, I do have one closure joke with a J. It's really a Lisp joke that I've reused for them. Turns out a bunch of hackers stole the last 50 megs of a closure program that governed nuclear launch codes. But it doesn't matter because it was all closed parentheses anyway. So. Feel free to reuse that if you like. You know. At any rate, you notice there's my single abstract method called accept. It takes a single argument of type T and returns void. So if you were doing this in Java 7, you would say, here's an anonymous interclass implementation of this. I'd say for each. Now, this for each method is a default method, actually. And if I look in iterable, here's the iterable interface, which we used for years before the for each loops came along. They have added a default method called for each, which takes a consumer, performs the given action for each element of the iterable until all elements have been processed or the action throws an exception. So right now, iterable is an interface. Collection implements iterable, or extends iterable, actually, I suppose I should say, because they're both interfaces. So collection extends iterable, and therefore inherits this for each method automatically. So I can simply go on my list here, dot for each, and supply a consumer. So if I said new consumer of type string, and I override the accept method to simply print out the argument, the important thing to notice is there's one argument coming in and nothing coming out. And that would be the way we would do this in Java 7. In Java 8, this is the lambda expression equivalent. Let me show this too. So you can still see consumers, the interface, here's the accept method, and this is the body, this is a lambda expression. Now, the way you tell a lambda expression, they always have an arrow, always. In Groovy, you don't need it. In Java, you do. You have to have something to the left of it. Here, you just pick a variable name. It's a dummy name, just like a Groovy argument. And to the right, you either have a single expression, and then they call it an expression lambda, or you can have curly braces and a bunch of lines of code, a bunch of statements, and that's called a block lambda. If you have an expression lambda, as I do here, you don't even need a return statement. Now, in this case, there is no return anyway, but even if there was, I wouldn't need one, because automatically whatever that expression evaluates to is returned as part of this. Now, this is the part that jumps out at Java people. As you notice, there's not even a data type there. It doesn't say string, which is really weird, except this is still being resolved at compile time. What's basically going on, now again, this isn't exactly what's going on because I know they've optimized the heck out of these things, but conceptually what's going on is the compiler looks at for each and says, oh, that takes an argument of type consumer. What is the single abstract method? Oh, it's called accept. And it takes whatever the generic argument is and returns void. So they match this signature to the lambda. And if the number of arguments on the left is correct and the body on the right returns the right thing, you're good. And by not saying string, that means this only compiles if S is in fact a string, because in this case, it's the context that means everything. The context here is a list of strings. So the consumer must be of type string because it's being used on the for each method on a list of string. If I had a for each on a list of employee, then my consumer would have to take an employee as an argument. Now, can you say string? Can you put in a block? Yeah, I got that example right below. Once you put in a data type, or if you have multiple arguments, then you need parentheses. But you don't otherwise. And once I put in the curly braces, then I could put in multiple statements. Suddenly I need semicolons, and I would need a return, etc. So this is the full form of it. And of course, IntelliJ is very happy with Alt-Enter to say, oh, let's replace the lambda with an anonymous inner class. Or actually, let's Alt-Enter. Oops, not doing it now. Replace with lambda. That went to the simple form, and then I could say, oh, let's expand the lambda body. So now I got the braces, and then I can go to the argument, and it says, oh, do you want to expand the lambda to string S? In other words, if you use IntelliJ, this is one way you can learn the syntax. It's just by playing around like that. Eclipse supports it, but doesn't do that. Okay, Eclipse has supported Java 8 since Kepler, but from what I understand, it was pretty buggy. The next one, what was L? Pardon me, Luna. Yeah, Luna was fine, and Mars, of course, was good, and now they have Neon, and those are all fine in terms of Java 8 support. So Kepler technically supported, but really, once you got to Luna, then it was working fine. I still would use IntelliJ. Now, because this is a talk about Groovy and not Java 8, I want to summarize a couple of the other things. First of all, this is called a method reference. So you see the double colon notation here. And the double colon notation separates the class or reference, whatever I'm dealing with, from the method that I'm referring to. So in other words, if a lambda is basically a method being treated like an object, you know, because it's got that anonymous inner class wrapper around it, it's like I could use it as an argument or return it from a method or what have you, or assign it to a variable. Well, a method reference is referring to an existing method and treating it like a lambda. So that's the difference. And that's it. Now, by the way, just for completeness sake, I took that method reference, it could have been the lambda, and assigned it to a variable. To show you what that would look like, I assigned it to a consumer of type string called printer, and then I could just use that. And all of these things are very common, and this is very typical usage. So the key thing to remember is that with lambda expressions, there has to be a functional interface somewhere that they are assigned to. They're either the argument to a method that takes a functional interface, or they're returned by a method that returns one, and you can return them as return types. But you've got to pick one of those functional interfaces or define your own. You can define your own. Again, the only restriction is it has a single abstract method in it. Now, they encourage, of course, us to use the ones that were defined here because they're going to be used throughout the rest of the library, and they're going to be very common in general. So that's basically just lambdas. And of course, I could run this. I'll run it just for the sake of argument. But all it does is print out the elements in the string over and over, the strings in the list, pardon me, over and over. You know, nothing special here. Now, if I want to show one other thing with streams, and then I'll go on to the Groovy stuff. So there's my same list of strings, if you will. This is a list of strings. And now I have a series of methods, because this has got a test case where I put things through its paces. There is a method that has been added to collection called stream. Stream converts a collection into a stream. So the question, well, what's a stream? A stream is a pipeline that takes data from a source and passes it through to a terminal expression. It's like, wait a minute, what are we talking about? A stream produces elements one by one. It does not save them, it does not modify them, and it doesn't modify the original either. So it's simply producing values. Now, they'd like you to pretend that you've never heard of I/O streams because they went and reused the word for no good reason. None of the streams I'm talking about today are I/O streams. Now, let me not go overboard. The files class in Java's new I/O, files, java.io. No, it's whatever, the NIO.files class has a lines method that returns a stream consisting of each line in a file. Okay, so they have extra methods to produce streams, but this isn't what we're talking about. A stream simply takes values from a source and passes it through a series of intermediate operations until we hit the end. And each of these intermediate operations produces new streams or filters them, and then ultimately they're used up. Streams are one-use things. You've got to make a new one if you want to start again. The stream method is a default method that's been added to collection that will now take the elements of the collection and produce them one by one so that they will not be modified, but they can be processed. The collect method is used on stream again. That's a method on stream. And this they recommend this fluid coding style of chaining the methods together one by one. Normally write them vertically. It's very easy to read that way. It's also easier to debug that way and to comment things out if necessary. By the way, the debuggers will step into these things. They're pretty good about it. At any rate, the collect method is a method on stream that produces a collection. So if stream goes from a collection if the stream method goes from a collection to a stream, then the collect method goes from a stream back to a collection. What I have added here is the argument to collect should be of an interface type called collector, but there's a utility class called collectors with an S, has a static method called joining. What it does is it produces a collector that will ultimately let the collect method get all the strings back and join them using the delimiter here, white space. So in other words, this would put all the strings back together again into a single string again, separated by white space. And you could use commas, any delimiter you'd like to specify will allow you to go from a collection to a stream back to a collection if you like. Now, that's not real common. You generally want to modify the elements of the stream in some way. And when I say modify, it'll produce new values. But regardless, here it says join uppercase. We take the strings, produce a stream, and then here's the method reference to the, maybe I can magnify that a bit, to the toUppercase method in the string class. And the map method, again, pretend you never heard of Java maps, the map method should have been called transform, because what it's doing is it's saying transform each element of the stream by invoking the toUppercase method from string on it. So each of these strings that was passed in, up here, this is a list of strings, becomes capitalized, this is a list of strings, and then I do collect, and what you'll see here is I've used the static import for collectors. Now, most Java developers were never terribly comfortable with static imports, never really happy about them. And I sympathize. I like seeing what class things come from. The biggest use of static imports in Java is the JUnit tests, right? Because at JUnit 3, we were accustomed to having assert equals and assert true and everything in the superclass. And then in JUnit 4, that went away. There is no superclass. They're all static methods in the assert class. So everybody does a static import of assert.star, and that way you can still write assert equals, assert true, assert same. Well, in Java 8, there'll be two classes people use static imports for a lot. One of them is collectors, because of the ease of reading something like collect these elements joining with a space. The other will be comparator. Comparator, which we've used for sorting all these years, now has a ton of default methods and static methods in it to make sorting, as I say, turning Java into SQL. You'll see how all that works. They even have group bys and partition bys and everything in there. So this one transforms the elements into uppercase and then joins them back again. Let me skip that one for a minute. This one, on the other hand, says, let's do a map, but there's map to int. And this is a pattern you'll see in the Java API over and over and over again. Whenever they have a method or a class that takes a generic, if it's possible for that generic to be a primitive, then they have a specialized form for ints, longs, and doubles. So there's stream as an interface, and then there's int stream, long stream, and double stream. I just showed a map method up here. There's also map to int, map to long, map to double. And they recommend you use the ones that go to primitives if they're available, if for no other reason than they are much, much faster. I mean, on the order of, my simple tests have shown roughly 50 to 100 times and maybe more in terms of speed. Also, yes, sir.
No, just impressive.
Yeah, it really is fast. And there's also, when they know they have ints, longs, and doubles, they add extra methods. Like there's a sum method in int stream. There's an average method. There's summary statistics. So these things have all been added to the language. So if you can use the primitives, you try to. It's not required, but it can be very helpful. But I've seen a demo of doing a sum of a stream of long versus a long stream, and that's, I say, it's 100 times or more in terms of difference. Any rate, this is using the method reference to invoke the length method on string. So this converts my stream of strings into a stream of integers, and then this sums them up. See, I have a sum method now because now I've got an int stream. In fact, you can see when I say map to int, it tells me that the return type here is something called an int stream. The argument's a toInt function. A function is one of those new interfaces that takes one input argument and returns one output argument, possibly of different types. Okay, so there's one. Also, we have things like stream itself has a static method called iterate. This, in fact, is big decimal.1. I just did the static import. And so iterate takes a seed and then a lambda to say how to produce the next one. So it starts with 1 and invokes the add method to add 1, and this is basically allowing me to count in big decimals. And I also don't have a limit on that. That's an infinite stream, so there's a limit method that will say I only want this number, and then I'm mapping them to doubles to pull the double value out and adding them up, which bothers me because I should be doing the sum in big decimals, but they don't have a sum. There is no big decimal stream. And there's no sum method. In other words, I have to do something to do the sum here. So it's kind of a hole in the library. But I just wanted to show the process. Okay. Let me skip the reduce ones, and that's so that's the basic idea. Now I want to show a map filter reduce as well, which I think I have. Heck with it. I'm going to write one. So this will be map filter reduce. And again, this is Java, so everything has to be in a class still, you know. And then I'll show you the Groovy equivalent. So
You've been going for a half hour, maybe you want to take a break in a little while.
I think
I don't know if you're coming to it.
Oh, actually be easier just to keep going if you don't mind. You okay with that, or?
Just one.
But I do need to get moving to Groovy though, so I do want to get to that. So, okay,
Keep going.
okay. So again, if I did my normal, you ever hear the cap design pattern? By the way, very common cap design pattern. Stands for copy and paste. The goal is to take an error in one part of your code and spread it throughout the whole code base. Yeah, maybe it's just me. I don't know. Anyway, there's my list of strings again. What I could do is I could do the following. Is I could say strings dot stream again, and then I will do my map, and I will, let's do a map to int, where again I'll invoke the string : length method, so that now I have a stream of integers, and then I'm going to do a filter. Filter takes something called a predicate, where one argument comes in and a Boolean comes out. So I'm going to say, oh, I'm going to filter them only by the ones with a length that's even. So I'm going to say, let's see, I need a variable for my lengths. I don't want to call it L. I hate using L as a variable name. So I'll just call it N or something. And then I put in my arrow, and I'll say N mod 2 equals 0. And that returns a Boolean, N mod 2 equals 0. And that will invoke that for each element of the stream, and then only return the elements of the stream that satisfy that. And then I'll do my collect. And then in the collectors class, there's a method called toList, and there's one called toSet, and there's even a toMap, etc. And it's not happy because, because I happen to be at this point an int stream, and I can't just do it with an int stream. So there's a trick here actually, is that I can do a map to object, or I think there's actually a boxed method, believe it or not. I'm not going to use that one, but the box method, oh, I'm sorry, I was going to do, yeah. What box does is it wrapped all the integers. So I had an int stream, now I got a stream of integer, and then I could turn them into a collection. And when I do my introduce local variable, it'll say, okay, list of integer now, which I'll just call ints or something. And then you see I have my integers. And this process of map, filter, reduce is the one that they recommend over and over and over again. And then I could print them out, or I could use them, or do whatever you like. Okay. Now, on the Groovy side, to see what that looks like and why it folds up like that, I still don't know. Just add everything up. Oh, I do promise to finish on an example that is not Java related, but it does have cat pictures. So that'll be, you know, your reward for sitting through all this stuff. Here is a, well, actually, let me do it this way. Here's the Groovy console. How's that font size? Do you see that okay? See, 2 + 2. I'm a Groovy developer. Resume-driven development, as it were. You know. At any rate, one of the things I like to show Java developers when I talk about Groovy is the dynamic variable conversions that happen automatically. Like if I said def strings equals, this is a list of strings, and then I invoke the split method, and I print them out, and I print out the class, and what you'll see is that there's my list, but this is the weird toString you get printed out when you're dealing with an array. So the return type on split is a string array until I change the word def here to list, and now it's an array list. You know, so I love that, and I like showing that to the developers there. So at any rate, if I have a list of strings, then how would the same map, filter, reduce look? It's very simple. In Groovy, it's strings. Now, preface, in Java, all these added methods were on an interface called stream. In Groovy, we already have the methods, but they're already on collection. So we don't have to transform to a stream and then go back. So if I simply say, what do I want to do? I want to transform them to length. So I want to do a collect, and I want to say it.length, if you will. Actually, since I like Groovy, I use it.size. You're familiar with that, right? Getting, yeah, size method on everything. And then I could do my my filter, which would in this case be a find all, where I go it mod 2 equals 0. Now I probably would use variables rather than just using it here. But I'm actually done, aren't I? Yeah. See, there where I don't have to turn it back into a collection and print it out. It's already there. So that's one benefit. Now, there is a a downside to Groovy, because in most things, Groovy is going to be much more terse and much more calm, because Java did add functional capabilities, but it's Java, so they did it in the most verbose way possible. You know, there are some downsides, and I want to show you an example of something that actually Java does better than Groovy, and that is with my lazy streams. So here's my lazy streams. Now, look at this method right here called first even divisible by 3 is what I'm basically saying. I really want to look at the range of numbers between 100 and 200. I want to double them all, and then I want to find one divisible by 3. And I only want to find the first one divisible by 3. So the stream way to do this is to start off, because I know I have integers, I'll use an int stream. That provides a method called range, which is just like a Groovy range, except this one's not inclusive. There's also a range closed method, which would be inclusive, okay? And then I'll do a map where I just say for each x, I want x times 2. Now map takes a function as an argument, one argument in, one argument out. Then I do a filter where I divide my predicate, says is it divisible by 3? Each element divisible by 3. So after this map, I have all my doubles, if you have numbers between 200 and 400. And after the filter, I have only the ones divisible by 3. And then I say, oh, but just give me the first one. Now, I don't want to get into this now, but I'll comment because the code is here. Find first actually doesn't return a value. It returns something called an optional. An optional is a new class that wraps values that may potentially be null. And if the stream after my filter was empty, then find first wouldn't know what to do, and they'd want to return a null, but we don't want to return a null because we don't know whether null was a legitimate return or not. So we use this find first in a library returns an optional int in this case, and it has a nice little method called or else. And what the or else method does is it says, look, if the optional that was returned has a value, just return that. Otherwise, return the default that I specified here, which is I said, if there are no values in the stream, return 0. But I can pick any default I want. Okay. So this is the mechanism. Now, this will work, but this isn't going to show you the actual method calls. See, the problem here that I'm looking at is, so I'm looking at this, I go, wow, does that mean that I went and doubled all 100 numbers, and then I went and did mod 3 on all 100 numbers, to filter them down to a third of them, and then say, oh yeah, but I only want the first one? I mean, that's a lot of wasted work, right? So down here, I'm going to do it with method references instead, because what I've done is, see this little multiply by 2 guy? I made a method called multiply by 2 that prints out, hey, I'm inside multiply by 2 with this argument, and then return it. And likewise, I did a divide by 3 that's got a print in it and return it. Now, I could have just turned it into a block lambda and written the print statement in there, but it's very common to try to keep the fluent interface as clean as possible and put your complexity in the method you're calling, just to make it so it doesn't get horribly difficult to read. And that's what I'm doing here. And so this one's going to do the exact same thing, except you'll see the methods being called as they go by. And what I have here is I've got a Java, a Groovy test specification, Spock test, where I'm going to take my lazy streams and I'm going to say, I expect the first even divisible by 3 to be 204. And then here I'll do it with the verbose method as well in Java. Now, before I run it, I want to show you the Groovy version too. And in the Groovy version, it looks like this. See, I use a regular range, square brackets. And then I call collect to double them, because collect says take a collection and produce a new collection by applying the closure to each element. And then I applied the find method, which will return the first element that satisfies the closure. It mod 3 equals 0. So the only difference here is that I didn't have to convert to streams. And here, to make it verbose, I actually used, by golly, I used a semicolon. So I put in print line it before doubling it and print line it before the modulus, but just to keep it nice and simple. It's the same code like that, okay? And what I want to show you back in the test is that, first of all, this test should be fine when I run just this one. That comes out green without a problem. But it's the verbose one that's the interesting one. And what I did here is I said, when I do this with Java, then the answer should be 204. And then when I use Groovy instead, see, this is calling the LSGZ one, or the lazy streams with Groovy, I should get the same answer, but the print lines inside will print out the numbers as they go by. So let me demonstrate this. And what you will see is that for the Java one, all I'm hitting is 1, 2, 3, 4, 5, 6, 7 numbers, and I'm done. Because basically what happened is it took the first element of the stream and it doubled it, and then it checked it against the filter and it didn't pass. So it went to the next argument, and then it doubled it and it checked it against the filter and it didn't pass. So I went to the third one and it doubled it and hey, that was divisible by 3, and then printed, and we're done. That's what they mean by lazy streams. Whereas the Groovy code, which was using collect and find and everything, went through every single number all the way through. And you're like, oh my goodness, what are we going to do? Are they going to make the Groovy collections lazy? Well, the answer is simple. The same streams in Java work in Groovy. So I simply took the same Groovy code. Here's my Groovy implementation, and I just did a range closed with a map and a filter and a find first. And the difference here is that in the Java API, they expect lambda expressions or method references. In Groovy, I put in a Groovy closure. Wherever you see a lambda expression, use a Groovy closure, and everything works. Groovy closures actually have more power than the lambdas, but they do work where the lambdas are expected as long as I don't violate their contract. And again, the contract on the map method is it returns a single value, and I did. And the predicate interface is that I return a Boolean, and I did. And therefore, it worked just fine. Okay? So worst comes to worst, you simply use, I mean, if the laziness is more important than anything else, then I have the test down here just using the streams as well. And when I run that, then again, I'm only seeing the same set of small number of values that I saw with the Java approach as well. Okay? So they do, now, Groovy does not yet support Java 8's lambda syntax or its method reference syntax as is. You can always use Groovy closures for lambda, and the method reference syntax is something you may not have seen very often. Here, remember, I did, no, this is not one where I could replace it. Here's my it.size, for example. Say I wanted to do this with the streams, I would say strings.stream again, .map, and then this, I need to, maybe I'll even do map to int, I suppose. And now I need to provide a function that takes in a string and produces an integer. Now I could simply do, s arrow s dot size, and then I would be fine. And then again, I could do my find all it mod 2 equals 0, and I get the same answers back. If I want to see the method reference approach to this, then now I need my parentheses. I would say string : length, and it'll say, wait a minute, I don't know what that is. It doesn't know the double colon syntax. But if you've used Groovy for a while, you know that the $ampersand allows you to use a method, and it's not happy with the value type. String.length is applicable. It doesn't like it? Pardon me? Well, no, the actual method in string is length. So I did actually want to use, see, it even says possible solution length, Okay, I'll have to figure it out for a moment. So actually, if I say this, that takes a function from string to integer len, which I'll borrow length, and to see if I can use it as an argument here. Otherwise, I'll move on and I'll fix it in the code. No, import statement. Java.util.function.star. And again, it's just not, it doesn't like the map to int method on my proxy, apparently. So I'll have to check it. I have other examples, though, with method references. But again, I don't use method references in Groovy that often, because when they're using a method reference, it's simplifying their code. When I'm using a method reference, where I need to in Groovy, I could just use it, you know, as a single value. And it's so simple already, we don't generally need the other approach. Just to prove that I do have an example with a method reference in it, this is the tiniest DSL you ever saw. So here I took, that's my problem. I'm treating length like it's a static method. That's what I'm doing, isn't it? If I go back here and I say, let's actually, I hate taking a string, right? But let's go ABC dot, you know, amp ampersand length. No, that's not it. I'm glad. I would have been unhappy if that worked. Any rate, here I made a list. And here I'm referring to the add method and the remove method in list. And I just gave them names, add to cart, remove from cart. So now I can invoke add to cart, add to cart, add to cart, remove from cart. See, I put in milk, butter, eggs, and then the double chocolate fudge, and I took it out, you know. It works just fine, you know, because what I've done there is I have basically made aliases for those methods and then used them as my trivial DSL, if you will. So a lot of Groovy developers have never seen the method reference syntax because it just doesn't come up that often. And there's an example. Okay, so I do have one in the GitHub repo. I'll fix the one that I was talking about before, and I'll push that up there. All right, let me move on to something more interesting. Let me talk about sorting, and then I will go to the higher order functions, and then that's about all we'll have time for. So first of all, here's Java. Sorry, that's Groovy because I was already in that. Sorry. Here. Okay. So again, there's my list of strings. Now in Java, the default sort is in the collections class, and it returns void and takes a list and does an in-place modification of the list, a destructive sort. In the functional programming world that this is all designed for, that's horrible. They never want to do that. Okay, everything should be immutable if possible. Java still has no good way of producing immutables other than Groovy's add immutable annotation, right? AST transfer. But there really is no good way in Java to do that. So I'll start with this, but then they've added something better. And what they've added better is that here I took my sample strings and turned them into a stream. And on stream, they have added a method called sorted. And sorted produces a new stream where the elements have all been sorted in their natural order. So it assumes that the elements implement comparable, okay, so that they can be compared, and it produces a new stream, and then I can collect it back to a list if I wanted to print it out. Now, if I didn't want to sort in the natural order, back in Java 7, I would use a comparator. I would say sort my sample strings, and here is our anonymous inner class, new comparator, override the compare method with 2 strings, and return subtracting the length. It's probably the easiest way to do it. Okay, and then again, it's a destructive sort, and that's what I would have. Now, first of all, even before I go to streams, comparator is a functional interface. It has a single abstract method called compare. There it is. You see the signature of that method? Takes 2 strings, returns an int in this case. Well, I can provide a lambda expression here that, again, takes 2 strings and returns an int, and provide that as the argument to the type comparator. And the lambda expression will be taken as the implementation of the comparator interface. So that, yes, they've added a ton of extra interfaces to Java, but the old ones that satisfied the functional interface requirements still work. And you can still use them with lambda expressions, and in fact, they're expecting us to now. So if you want, you can simply already gain by doing this. Now, by the way, they've added a compare method to the integer class that avoids any potential integer overflows when you do subtraction. Now, when I'm subtracting lengths, that's not going to happen. But if I had a big positive integer and I subtract a big negative integer, I could get an overflow. Compare takes that into account. Okay, now, down here, on the other hand, is the way they would recommend you do it in Java. The sorted method on streams takes a comparator. And that's what the documentation says. Although I got to tell you, when you start looking at these guys, you're going to see the ugliest generics code you ever saw in your whole life. And if you've been ducking generics as much as possible until now, those days are numbered. Just warning you. You know. But at any rate, here I provided the comparator. Now that's fine. You can provide a comparator, but in comparator itself, they also put in a whole bunch of static methods and default methods, one of which is called comparing int. And the argument to comparing int is, what's the key that you want me to sort by? And then I'll sort the keys and then sort the collection. And you see how this being a static method on comparator, this will benefit from a static import, because what I'm going to say is, take my sample strings, turn them into a stream, sorted by comparing int with the length, collect them back to list. And that's what it'll look like. And they've added a default method on comparator called then comparing, so that I could actually say sort by length, then by natural order for equal length strings. So I could sort by one property, then by another for equals, and then by a third, and on however I want, all using these methods in the comparator interface, the thing we've been using for years again. And this is what I mean by turning Java into SQL. Okay? And we used to have to write that code ourselves. And I even went a little more here. I said, actually, this is the same thing, just with the static imports in it, comparing by length, then comparing in natural order. And then here I went, then comparing by length, or comparing by length, then comparing in reverse order, for example. And there are a whole bunch of variations on this. And it's actually really nice. It gets to be very powerful. And I have lots of other examples. But let me show you the Groovy one instead for a moment. Okay, first of all, when I created my initial set of strings, I just did my split and assigned it to a list. Here's your default sort. They added sort to collection. Actually, that's not true. They added sort to iterable. It used to be in collection. They moved it to iterable. So I always look in the wrong place and they go, oh yeah, wait a minute, it's in iterable, and then I have to autocorrect. At any rate, so there's your default sort. Sort also takes a closure, and I'm using Elvis. And well, I'm not Elvis. I'm using Spaceship here. Spaceship. That's always a segue for the Lego movie. But at any rate, where I'm just comparing the sizes. Or if you look in the Java docs or the Groovy docs for the sort method in Groovy, it also takes a one argument closure where you simply specify the property to sort by, and there you go. Sort by length. That's how easy that is. Now, of course, if you want to sort by length and then equal lengths alphabetically, that leads me to one gag, is I take my S1 and S2 and I use my spaceship to sort by length. And if that is not, see, I've got an Elvis operator here. So if that is 0, -1, or 1, then it just returns it. I'm done. But if it's going to evaluate to 0, the lengths are equal, then I do the Elvis or the spaceship comparison with the strings themselves, which is the natural order, so that they're sorted by length and equal length alphabetically. Or more properly, Elvis is being returned to his home planet by 2 tandem spaceships, meaning it's the fat Elvis from the 70s and not the thin Elvis from the 50s. I know it's a long way to go for that gag, you know. But again, that's the Groovy approach to something like this. And this might fall in the category of getting too cute, but I just did it for the gag anyway. But again, the same collectors interface, all those same methods still work in Java. Now, if I go back and look at a class, I can make life even easier. Here is a class called Golfer that has a string first, a string last, and an int for the score. And I've got some constructors. I put in a compare to method so that the default sorting is by score. I've got getters and setters. I have an equals method, a toString method, and a hash code method. I mean, that simple little Pojo is, 77 lines, right? And then here's some sorting being done with them using these mechanisms I just mentioned. So I made a set of golfers that had some equal scores and some equal last names so I could play around. And the default sort would be stream, sorted, and then for each just print them out. Notice how system.out : println is a method reference to the println method in system.out. Here, sort by score, then by last name. I could say sorted, and here's the comparator.comparing int will compare by the score. See the method reference for get score. So that's the key. Then comparing get last. So that's the last name. And all of that will produce a sorted stream, which again I can print out. Or I can go nuts and say first we'll do comparing int by the score, then comparing get last, then comparing get first. And boy, that's so much nicer than anything we had before in Java. That people will be using this a lot, and you can see why they're going to start doing some static imports for this stuff. We're not going to have time to go over, but just to point out, I also put in a partition here where they have a partitioning by, and that takes a predicate, takes in a single argument, returns true or false, and will give me back a map. These are all the ones that are true. These are all the ones that are false. So I'll get a map of Boolean to list of golfer, all the ones with a score less than 70 and all the ones with a score greater than 70. They also have a group by, which will create a whole category and put them all in there, again, in the quest to produce SQL when we want it. Now, again, the Groovy approach to this. First of all, there's my Groovy golfer, if you will. First, last, and score, right? That's all I need. Normally, what I would put on top of that as well is a canonical AST transform to give me all my extra constructors and toString and equals and hash code. But this time, I'm going to use sortable. Sortable automatically generates sorting methods for a class that sort by the first element, then equal first by the second, then equal second by the third, top down. Now, in this case, that's not what I want. I don't want to sort by first name, then last name, then score. So you can put in an includes block in your annotation to say what order you want them to be in, or you could leave some out. There's also an excludes. And I put in my own toString method simply to print out score, comma, score with last and first. Easy enough to do. So already the Pogo is so much simpler than the Pojo. And now to do the actual sorting, first of all, wrong one, here we go. This is it. There are my same golfers. Now, by the way, these are the Groovy golfers, and I'm using the named constructors. You can do that with a Java class if you're not aware. Even if all the Java class needs is a default constructor to make this work. And then it'll go from there. And if you really want to freak out your Java developers, and you probably don't, but if you do, do it on a Java class that doesn't have getters and setters. And then they say, wait a minute, what happened? Well, it set the private attribute. Wait a minute, that's violating encapsulation. Yeah. Sort of. It's using the same reflection that Hibernate uses or Spring uses. Anyway, you could open up that entire can of worms if you feel like it, okay? By the way, here's how my path out of that can of worms, and this sometimes works, but not always, but you could try this. I say, all right, here's my explanation, which is either an explanation if you agree with me or a rationalization if you don't, okay? It's that private doesn't mean security. Private means this is an implementation detail subject to change without warning. And if you code to it using reflection and I change it, your code's going to break. It's not my problem. I told you what parts were public and what parts were private. But you can get to it if you want at your own risk. And therefore, Groovy's simply making it easier to avoid writing all that reflection code. If you ever use JPA, many people put the annotations right on the private attributes. It's the same thing, okay? And they just don't talk about it. Now, some people will go, okay, I can live with that. And a lot of people are going, no, I don't like that. But at least there's your start for your argument. The fallback position is, yeah, it's a bug, but it's such a useful bug, they're never going to fix it. So whichever one works for you. Okay, so at any rate, when I put on my @sortable AST transform, now there's a method called toSorted. I could also use the regular sort method, but this toSorted provided by the transform. Now I could say, oh, go to the first one and get the score. Go to the first one, get the last name. Or get to the last one and get the first name. Or I could print the whole scoreboard just by doing a print. By the way, this is what the method reference would look like. I just commented it out with the @print line. But you can even print out just the last names. I mean, I got to run this just to show you what you get. And you can see, if you could see it, let me move that up a bit. There's my scores, 68 through 70. There's the last names. Nicholas ahead of Webb, Watson's ahead of Wood, and Bubba's ahead of Tom because they're alphabetical again. Okay, just working it out one by one. The asserts all worked, and by the way, I could just say sorted.last, and there's the collection of last names. Comes out automatically. And this is the sort method in collection. False means don't modify the original. Produce a new one based on this key. So again, it's great that they did all this work in Java to make it simpler to do sorting, but it's still never going to be as simple as the Groovy version there in general. Now, I know what you're thinking if you ever saw Caddyshack, okay? Tell me you saw Caddyshack, right? Judge Smales says to Ty Webb, saw Ty Webb's right here. See, I got Ty Webb in there from Caddyshack, you know, Chevy Chase in the movie. So, Ty, what did you score today? Or what did you shoot today? Oh, I don't keep score, Judge. Really? How do you compare yourself with other golfers? By height. So I'm not going to show it, but if you look in the code base, I also have my Caddyshack golfers that are sorted by height as well. Okay, so that's all in there in case you need it. And then there's other examples as well. So just giving you an idea. Okay, now things that go beyond what Java has built into it. I'll just give you a couple of real quick ones. First of all, Memoize. Here is an add method that has a sleep condition on it. Now this is, again, the sort of thing you can't really do in Java. I've created a closure and assigned it to a variable. The closure takes two arguments, x and y, sleeps for a second, and then returns the sum. Now I didn't put data types, so I could use this on strings, I could use it on integers, I could use it on a date and an int. You know, any class X that has a plus method that takes a y, whatever it is fine. I put the sleep on here because what Memoize does is it internally creates a cache where the method call is the key and the answer is the value. And every time you call a method, it will add that to the cache. And let me say it the other way. When you invoke a method after Memoize, it will first look in the cache to see if you called that method before. And if you have, it'll simply return what it did already. And if it didn't, then it'll invoke the method and add it to the map. So here I'm going to call add with 3, 4, and then I call it again. The first call takes a second to run. The second one's immediate because it's already in memory. It's already in the cache. Likewise, A and B takes 1 second. A, B, immediate because it's already in the cache. Cool, dangerous, brings up the whole cache invalidation problem, right? And it's one of these so-called hard problems in computer science, right? Along with naming things and various others. Exactly, thank you. And it's just called, the method is simply called Memoize and has been added to collection, pardon me, to closure. I'm trying to magnify this again. It's in the closure class called Memoize, and it returns a closure again where it creates the caching variant, etc. And you could read the documentation, but it's just what I described. Now, here is your classic example where you need something like this is a Fibonacci number calculation, right? You say, oh, well, Fibonacci says, well, if n is less than 2, return 1. Again, I like put the 1 there just so that they don't see the return statement. But I really wouldn't do this in practice. I don't like being obscure, you know. Which reminds me of a Perl joke. See, Groovy, I always say, doesn't make the shortest code possible. That's Perl, you know. It makes the cleanest code possible that's still readable, which I do have a Perl joke. 1 million monkeys typing in 1 million typewriters will eventually type a Java program, and the rest will be Perl programs. Yeah, okay. Any rate, in my Fibonacci closure here, I put in the call method. Remember, closure has a call method in it. So here I'm saying if n is less than 2, return 1. Otherwise, call fib for n minus 1 plus the call for n minus 2. And if you've ever seen the combinatorial explosion, you know, once you call Fibonacci of 5, then it's calling 5, which is calling Fibonacci of 4 and 3. And 4 is also calling 3 and 2. And now I've got 3 in multiple places. And then 3 is calling 2 and 1. And you can have multiple ones. It gets bigger and bigger as the tree grows. Well, with Memoize, now all of those previous calls are saved. And now I've turned this into an iteration, basically. And if I do a Fibonacci of 10, it's no problem at all. And even better, there's now an AST transform called Memoized. So that here I couldn't do it because I need to have a method for this. Memoized only goes on a method. So I say fib1 here takes a long, and it's the same thing except it's actually calling itself this time. And I put Memoized on it, and now I could do Fibonacci of 100 and get some giant number, which should happen. I mean, it happened that fast, you know. Whereas it's not that the number's all that big, it's that the stack would have been enormous if it had to compute all of those intermediate results. And that's the benefit here of Memoize. Java has nothing like that, but we can always use that in Groovy. Another thing we have is good old trampolining, which again is a mechanism to take recursion and turn into iteration. You simply have to have a way to call yourself with the right arguments. So here again, I'm going to create a fact method, closure, and it takes 2 arguments. See, I have to have 2 arguments this time because what I'm going to be passing is the number I'm calling it on and the running total up to that point. So that all I'm going to be doing is adding the number onto that total. So here I say is n 0, then return the total. Otherwise, call the trampoline method with n minus 1 and n times the total. And I'm going to start this with a 1. So here, and I call trampoline at the end. So now factorial is for n, call this fact with n and start it with 1 as a big decimal, G for big decimal. And now I can do factorial of 20, and it happens very, very quickly because I've turned it into iteration. Here I'm doing it with big decimals. So here I put in 3 arguments. There's my number. Here's my big decimal of 0. Here's my big decimal of 1. And this time when I call the trampoline, I'll call it with n minus 1. And then B is going to be the running total. And A is going to be what I'm going to add to it, A plus B. And here I ran fib of 1001. I didn't even bother printing it out. I just printed out the size. It's 209 digits long, you know. Now this one, I always have to think through. But if you can structure your problem to take advantage of it, again, Java has nothing like that, okay? And then the other small example I have that's something that Java doesn't have is tail recursion, which is one more attempt at this. There's actually an AST transform called tail recursive, so that you don't have to write all that code I just talked about with the trampoline. You simply say, okay, here's n, and here's my accumulator, which I'll initialize to 1, big decimal 1. Let's put my imports here, big integer 1, pardon me. And then I'm going to return n less than 2, return the accumulator. Otherwise, call yourself with n minus 1, and here n times the accumulator. This one I understand. This one I can write right away. And here I'll print out the factorial. I ran it with 70,000. And again, I got a number that was 308,760 digits long. By the way, did you know you could do this? This is from Java 7. A lot of people miss this. You can put underscores inside of integer literals just for readability. They're ignored, but they work. It's the only delimiter you're allowed. You can't put commas. It'll still get messed up. But underscores in the middle of an integer literal, go, yeah, that's fine. So this one's really cool because this basically sets up the whole trampoline for the tail recursion for you.
It's even more important because in order for that to work,
yeah,
your call, recursive call, must be last in your body. And
right.
Sometimes it's not that obvious. And this, as I understand, will actually confirm that it is.
Thank you. If you didn't catch that, that's right. This here, the factorial call to the recursive one has to be last. And then, and as you say, tail recursive will likely check to make sure that's true. And the docs say class annotation to transform a method with tail recursive calls into iterative methods automatically, since the JVM cannot do this for itself. Does it have that restriction on there? Only non-void methods are handled. Yeah, I'm sure that, at any rate, there's lots of documentation in the Groovy docs about that. So yeah, thank you for that. At any rate, this is the stuff that's going to go beyond most people for a long time, and that's fine. I mean, it's just, you don't have to adopt everything. You can just pick up the parts that are useful at first there. Okay, now, was there anything else major I want to show you before I go to just the finish here? I will show you, by the way, here is closure composition in Groovy, in case you haven't seen it. Here's an add 3 method, closure, if you will. Just it plus 3. Here's a times 2 closure, it times 2. And then they use the left shift operator to compose the 2. The only problem for me is that it feels backwards. But at any rate, this will multiply by 2 and then add 3. So I can go times 2, add 3, that's my new one, and check that it multiplies by 2 to get 10, then adds 3. Here I do them manually just to prove they were the same. And then if I use the right shift operator, I can do add 3, then times 2, or whatever. I mean, actually, no, that's the same thing, isn't it? So I've got both variations in there. That's closure composition, and it does work in Groovy. In Java, I do have an example somewhere where they have something like it. But I don't have it handy. I'm not gonna Not going to worry about it right now. But it is a mechanism that is useful. Yes, sir.
That they do it that way. In math, you say so F composed with G. That means first do F and then G is on the outside.
That's got to be it.
I had to, whenever I read that, I had to do the flip.
Because in math, they use a little circle so that it doesn't look so confusing. This is using the shift operator, and that makes me think I'm going the wrong way each time. But you're right. It's the F circle G. It's F composed with G, therefore F first and then second. Yeah, exactly.
I agree that it feels to be back.
Yeah. Now, the other thing Groovy has that Java doesn't have is currying as well. Java kind of fakes it, but they don't really have it. This is what currying looks like if you haven't seen that. Here's an add closure again. And then I could just call or just call it by itself. You know, that's built into the language. And I can call it with strings or with dates or with anything. But how about this one? May not have seen this. This is a Groovy puzzler, isn't it? ... space values. That means a closure with 0 or more untyped arguments. In other words, I'm not saying what the types are. It would be like saying def ... But you can leave out the def. How bizarre does that look?
And also number.
How many?
You are not saying what's the type, and you don't say how many of them.
Precisely. I'm saying neither the type nor the number. It's 0 or more. Now, inside the closure, it would be treated like an array, like they do in Java as well. So here I can do add all with numbers or with 2 strings or with anything I want, as long as it's legal to keep calling plus on each one of them. Here's a multiply as well. This one, now, by the way, again, in case you didn't notice, I've been starting to use some default arguments inside a method or a closure. Groovy allows you to do that. This says my multiply takes x and y, returns x times y. I'm initializing y to 2, which you can override or not. If you don't override it, you get 2. So here I could say multiply 3 and 4 and I get 12. Here I could say multiply 3 and it'll multiply times 2 and get 6. In other words, I wouldn't do this. I just want to demonstrate that it works. But here's curry. The curry method takes an argument and plugs it into the first leftmost argument of the closure, producing a new closure where that argument's already been set. So when I say add curry 3, I'm basically taking this add method up here and specifying x is now 3 forever. And I called that add 3. So if I do add 3 on 4, I'm going to do 7. And of course, before I show this to people, I'm going to have to put in one with a string so I can add a Steph Curry. Or I'm going to have to be able to do that. That's a bad pun, isn't it? But at any rate, moving on. There's also an R curry, by the way, if you prefer to curry in your arguments from the right-hand side rather than the left-hand side. And there's an N curry, which is dangerous because N curry takes an index to say this is the index I want, but if the signature changes, you're going to mess that one up. Whereas if you're always working from the left or right, you at least have a fighting chance. But either way, you need test cases. Okay. Java has nothing quite like this. You can manufacture your own methods that return closures that way. Okay. All right. So I wanted to mention that. And I think that's all the... Oh, there was my map filter reduce. I knew I had one in there. That's everything I wanted to show there. So let me show you the cat pictures, and then if you have any questions, I'll be happy to. Oh, actually, one other last thing here. Here's a Pojo again, called book. ID, name, and price. That's all it's got in there. Constructors, getters, and setters, the works. Say you have a collection of books, and you want to put them in a map where one of the properties is the key, you know, so that you're going to look them up quickly. Some people write the loop and add them in. Well, Java now has a way to make that easier. So I went to Amazon, looked up a bunch of prices. And then here's one option, turn the book collection into a stream. See, this is a list of books. And then again, collect with collectors has a toMap method, which takes 2 functions. The first function to produce the key, the second function to produce the value. So I'm doing get ID for the key, and then B arrow B, right? An identity closure, if you're identity lambda for the value. Or if you really want to confuse people, there's a static method called identity in the function interface, which does the same thing. But that tends to confuse people, but they both work. And remember, there's the for each method now on collection. They also added a for each method to map, which takes what's called a by consumer. That means 2 arguments coming in, nothing coming out. In this case, they separate the keys and the values for you, and then you could use them individually. But of course, if you're thinking about this at all, and if you've used Groovy for a while, you know that if you want to add books to a Groovy map, first of all, that's that same book class from Java. What the heck? And then here, you know, make an empty map for each one. Book map of ID is the book. I mean, it's hard to get much simpler than that. But all right, they're trying. You know, I mean, it's like having a little brother who's moving along, and you give them credit, you know, where they have credit, you know. I still don't see anything in Java that they can do that Groovy can't, except for those streams, except then we just take the streams from them. Yeah, we'll use your streams, no problem. Yeah, and that's fine. So Groovy goes beyond, and I try to tell people you could put these Groovy methods in a class, and from Java instantiate the class and call the methods, and everything works fine. Last example before I show the bigger demo. Here is a prime number checker, before and after. This is mostly for the people who haven't used Java 8 much, just to show you what it looks like. Say I want to determine if a number is prime, and this is brute force. But what does it look like? First of all, if x is less than 2, I'm just going to throw an illegal argument exception. And then I'm going to say if it's 2, yeah, okay, it's true. And what you need to do is divide by the numbers from 2 up to how far? Well, it's the square root plus 1 as an integer. So there's my limit. And then this would be the old style. From int I equals 2, I less than or equal to that limit, I plus plus. If x mod I is 0, return false, otherwise return true. And I've got to keep track of everything. This is what it looks like in Java 8 now. Again, same stuff for getting the limit. Return x equals 2, or there's my range closed. From 2 to the limit, there's a none match method in stream that returns true if none of the elements satisfy the lambda. And there you go. Now, of course, the Groovy version was always simple. It's just that we use our ranges to look like this, and we have a find method or a find all method. Find in this case, because I'm saying find the first number that doesn't satisfy this closure. That's why I got the not in there. And if none of them satisfy it, it's true. So we used find, they used, you know, none match. They have an every match and an all match. Groovy has all and every, you know, and any as well. You know, so again, they're gradually learning from Groovy what to do there. Okay. All right, cat pictures. I'm going to do that in a couple of stages, but I do have the pictures here. Oh, I need to explain where this comes from. So here is the API for Flickr's photo search. And you need to register. You don't need to authenticate, but you need a key, which means you need to register at Yahoo and get a Yahoo key, which is painful. But so be it. I went to the trouble, and it's in the code base. It's in the repo. You know, try not to do any serious damage. At any rate, if I scroll down, there's a whole bunch of inputs. And then ultimately, you get back. Now here they're showing an XML. I'm going to use JSON, okay? But in XML, you get photos element, photos, which has a series of photo elements that all have ID and owner and secret and server and title and various other flags. And what you don't see is the image. And then they tell you in the documentation how to extract these attributes and build the string that represents the URL for the JPEG. Okay? And this is all doing a GET request. So with that in mind, here's how I'm going to call it. So here I start off. My key is in the file called flickerkey.txt. When I call the getText method, I retrieve it. Here's the base URL, api.flickr.com/services/rest, ? Here are my parameters. I've got a method parameter. The REST advocates are having a bird at this point. Do you know what they call themselves, by the way, the REST advocates? Restafarians. I know, it shows way more sense of humor than these people normally demonstrate, by the way. They will argue into the ground over what is or is not RESTful, right? Any rate, remind me to give you the prime number joke too, I missed that. They used it here, and then there's my API key. I want JSON format. I'm gonna look for the tags called cats. That's been the most successful, okay? But it's whatever the users tagged with the word cats. Now, once I got tractors, I was like, oh, caterpillar, tractors, you know. But I've gotten dogs, I've gotten monkeys, I've gotten things that were arguably inappropriate. So again, I don't know, but I'll try it. I'm not doing a JSON callback. I want photos. I want 6 of them. Now, one neat thing I like to do is to take parameters and build a query string out of them in this simple little mechanism. Call collect for each key and value, return key equals value, and then join them with an ampersand. And then that builds a query string. And when I have time, I show people how to add that to the map interface, you know, all this stuff. So here's the full URL, is the endpoint and then this query string plugged into it. And of course, the Groovy JDK gives you a toURL method and then a getText method, and that'll download the JSON. I'm going to make a file called cats.json. If it exists, I'll delete it. I'll append my JSON text to it. I can even pretty print it so we'll see the data. Just so it's there, that's fine. Then I'm going to use a good old JSON slurper and call the parse text method on that JSON text. And then I'll drill down to those photo elements. Remember, it's still structured like XML, even though it's JSON in this case. So there will be a photos element, and then there's photo elements inside. So I'll grab them all. Now, what I'm thinking of doing before the conference is that the other thing that Java has that Groovy doesn't have natively is parallel streams as well. You just change from stream to parallel stream, and then it'll use all your processors. I've done that in Groovy with Jeepers. And yeah, I pronounce it Jeepers. Where's the joke otherwise? Yeah, Groovy Parallel Systems, great library. But Java did add parallel streams. So as a demo, it'll be great. I'll update this to use parallel streams. Okay, so at any rate, this grabs all the photo elements, and now I need a builder. And again, this is something that Java does not have. Java does not have a meta object protocol or anything like that. So I'm going to use a swing builder on the event dispatch thread. I will create a JFrame whose title is cat pictures, set visible to true, set pack, it's actually pack method, set default close operation. This is always interesting. WC exit on close. I aliased window constants as an import. A lot of Java, they don't realize you can alias your imports as well. So there's that. Layout is a grid layout with as many rows as I need, 2 columns, 2 pixel separation horizontally and vertically for each one. For each photo, call it P, this is the URL that the Flickr documentation tells you to put together. There's that farm attribute and the server and the ID and the secret, and apparently they're all JPEGs, okay? And there's the title. So I turn that into a URL, supply that to Java's image icon, because why not? Put the tooltip text to be the title and make a J label out of it. And there you go. That almost, but not quite, makes Swing usable. Almost. Okay. All right. Wish me luck. I mean, it's going to work. I just don't know what I'm going to get again. But there's the JSON getting spit out. And, okay, that's not a cat. It says cute cat. Oh, my problem there is that I'm not resizing them. A grid layout keeps equal sizes. Figured it was just simpler. So there's probably a cat in there somewhere. But the rest of them look like cats. Hey, you know. So that's always a nice demo. Right. So that's a nice demo. So what I'm going to do for the talk, I'm definitely going to do that. I'm going to take this and I'm going to switch from this each method in here to somehow do it with parallel streams. Because I knew I could do it with Jeepers with parallel streams. I've done it before. I even wrote a blog post about that once. But otherwise, there's that. So that's pretty much everything. There are a few other examples in there, but and if you have any questions, you know, just send me an email or whatever. But otherwise, that's the stuff. Any questions, comments, words of wisdom? Heard any good jokes lately? Let me give it. Oh, I was just saying for the parallel thing, you could add a sleep in there to make it clear that it actually is doing, because that was so fast. Yeah, because it's a network delay, and I don't know what that. I mean, I could add an artificial delay though. Absolutely. I also, what I like to do when I do parallel demos as well is I print out a thread.currentthread.name. So that I could see the name of the thread operating on each one. That's always dramatic too. So I've got some Java examples like that I'm going to have to bring up. So yeah, thank you for that suggestion. Let me give you the parallel number joke though, at least. So at least we have that. One question math test, prove or disprove that all odd numbers are prime. Okay. So the So it's because I didn't show it here, but here was my prime number test. Okay, I think that's you know, if I just remembered the name, I could have gone directly to it. At any rate, you see what I'm doing here is I'm instantiating the prime number checkers, both the Java and the Groovy one, and I invoke the isPrime, and I do it on the numbers, the prime numbers less than 20, and then I check that they're not prime on the composite numbers less than 20, including 20. No, not including 20, anyway, up to 19. And then I even check the illegal argument exception with thrown. And by the way, if you've ever done a Spock test where you want to use a range, be sure to use parentheses around this. That'll evaluate the range and supply the values one by one to the test. So that's a neat little trick. And then with the unroll annotation, I'm going to get them all listed. So that just to show that this works, if I run them all here, unfortunately, I can't magnify that, but look at that, 0, 1, 2, 3, 4, all the way up to 19, and there's the -1 and -2 with the illegal argument exception. It all works fine, and if I do it as a Gradle build, then it'll produce the HTML output, and I can magnify that and everything. That's nice. So at any rate, the joke is prove or disprove that all odd numbers are prime, and the mathematician goes, well, 3 is prime and 5 is prime, therefore by induction, all odd numbers are prime. The more math you know, the funnier that one is, by the way. The physicist goes 3 is prime, 5 is prime, 7 is prime. Oh, 9. Well, that could be experimental error. 11 is prime, 13 is, that's got to be enough, right? The engineer goes 3 is prime, 5 is prime, 7 is prime, 9 is prime, 11 is prime, 13 is prime. The computer scientist goes 3 is prime, 5 is prime, 5 is prime, 5 is prime, 5 is prime. And of course, the manager, 2 is prime, 4 is prime, 6 is prime. So, if nothing else, I leave you with that one, okay? I will be happy to hang out as long as you like. I know it got warm in here. I know I went long. Again, it's just a habit. I do appreciate your attention. And if you have any feedback to give me before, like I say, I got 3 weeks to clean this stuff up, you know, and actually make real slides. At least I don't have to use Oracle's template because I don't work for Oracle, you know? So they got that benefit to it. But at any rate, thank you very much for coming.
Thank you.
Can we stop the sharing?
Sure.
Okay, so I'll turn off the sharing.
Yeah, I'm just gonna stop.
Okay.
Yeah, I'm just going to conclude the broadcast here. So
And that you
Thank
put the GitHub repo and everything.